So let's start with the moon. So just some basics about the moon. So our moon is orbiting around our Earth. So the moon rotates on its axis and it orbits the Earth. And it takes about 4 weeks to orbit our Earth, or about 29 days. So as seen from the Earth, the moon moves west to east across the sky over a month. Now that means every day, okay, so if you go outside and you look at it at night and you see the stars rising in the east and setting in the west, the moon is going to follow that motion over one night. But night after night, week after week, you'll notice that the moon will move westward relative to the background stars. That's its motion as it's going around the Earth. Now we can see the moon not because the moon is emitting its own light. The moon is a dead, rocky body, has no internal heat. But instead, the moon reflects sunlight. It reflects sunlight because it has a perfect material to do this. It's made up of a gray, very dusty material. It's kind of, if you think about it, like snow. Excuse me. Snow reflects very well, and you have the bright, shining sun coming right off the snow. The moon is similar to that. This gray material is a great reflector of sunlight. So we're able to see the moon because it reflects solar light. So take a moment at these concept questions, pause, and think about the question. So what do you think causes the phases of the moon? The Earth's shadow covering the moon's surface changing light to dark, certain parts of the moon being illuminated by the sun, or certain parts of the moon being illuminated by the Earth. So pause this video and tell me what you think. Okay, so after you've paused and thought about this, you might have been wanting to answer either number 1 or number 3. Both are common thoughts of why we have phases of the moon, but number 1 is incorrect. The Earth's shadow covers the moon only during an eclipse. Otherwise, we have phases. So we only have eclipses periodically, but we have phases of the moon every month. So certain parts of the moon are illuminated by the sun, and it's how we see those parts of the moon being illuminated from Earth is what we call the phases. So the moon moves around the Earth, and we see different parts illuminated, these lunar phases. There's 4 main phases: new moon, first quarter moon, full moon, third quarter. Now, in between those phases, we have the moon is showing us more and more light. Okay, so we call that growing or waxing. So first, going from new moon to first quarter, we'd have a waxing crescent shape. Then going from first quarter to full quarter, we have a waxing gibbous. So waxing being growing. Gibbous is kind of a not quite circular shape, but more than a quarter, or more than what you'll see being half illuminated. After we have full moon, the moon's light starts to decrease. We call that waning. So we have waning crescent and then waning gibbous after we've passed third quarter. So let's look at what this is. So on this image here, I'll use my little pen feature. Somewhere in here, let's say, oops, maybe I can't use my pen feature. I'm trying this new video. Pen. So here we would start with new moon. New moon, somewhere in there. So new moon, then let's come to the top up here. So after new moon, we then have a waxing crescent. So this crescent shape. The waxing crescent till we get to first quarter. Then we have a waxing gibbous. Notice the kind of oblong shape here. Waxing gibbous until we get to full moon here. And then we have waning. So waning gibbous all the way to first quarter, and then waning crescent until we get back to new moon. So let's take the bird's eye view. And so what would this be looking like if we were able to peer down on the Earth and the moon? So notice the sun coming up from the upper right-hand corner. When you're in the position A, you're seeing a new moon. And that's because we're looking towards the sun, and so the back side of the moon is being illuminated by the sun, but the part we're looking at is shadowed. So we see that as a new moon. As the moon moves in a counterclockwise direction around the Earth, we move to waxing crescent at the B position, then at the C position, first quarter, at the D position, waxing gibbous, and now when the moon is on the opposite side of the Earth from the sun, the sunlight is shining fully on the moon and we see a full moon. Only then, when it keeps going around its orbit, will that moonlight start to decrease again into the waning gibbous, the third quarter, and then the waning crescent. So notice also when you would see the moon. So if you were able to look at the moon straight up in the night sky, or straight up in your sky, crossing that meridian, that line that goes from north-south through your zenith, if you were to see a new moon, and the moon was going across your zenith, you would be seeing this around noontime because the moon is between you and the sun. Let's look at first quarter. So around sunset, you'd be seeing a first quarter moon. And around sunrise, you'd be seeing a third quarter moon. And then at midnight, you'd be seeing a full moon. So the moon always keeps the same face towards us. And this is a result of what's called synchronous rotation. So look at the image on the left. This is if the moon did not rotate on its axis. Imagine you have a crater, this red crater that's visible from the Earth, and a blue crater visible from the sun. If the moon did not rotate, as the moon orbited around the sun, we would be able to see both craters throughout the lunar phases. But instead, we have something like the right-hand image, where the moon does rotate. And the unique thing is that the moon rotates at the exact rate that it orbits around our Earth. So that means that red crater always faces towards us. But this doesn't mean that the dark side of the moon, as they call it, doesn't get sunlight. It does, because I don't like to call it the dark side of the moon. Instead, I prefer to call it something akin to the side we don't see. So the side we don't see, it gets sunlight. Notice where it gets sunlight. It gets sunlight during a new moon phase. So that other side we don't see does get sunlight. It's not really a dark side of the moon. We just called it dark side of the moon because when we're looking at a full moon, it's on the dark shadowed side of the moon. But because it orbits in synchronous rotation around us, all sides of the moon get illuminated. And half of the moon is illuminated at all times. So what about lunar eclipses? So lunar phases work because the moon is tilted 5 degrees with respect to the plane of the Earth's orbit. When the planes line up, that's when the Earth, the moon, and the sun are all in a line, and that's when we experience both solar and lunar eclipses. When the Earth's shadow falls on the moon, we get a lunar eclipse. So let's look at this. Here's the planes of the Earth and the moon. So the blue plane is the ecliptic, that path of Earth going around the sun. The moon's plane of its orbit around the Earth is tilted about 5 degrees off of the ecliptic plane. This means that the moon is a little bit higher or lower than Earth in terms of being lined up with the sun. But when it's lined up exactly on the nodes where the two planes intersect, that's when we can experience eclipses. So here's a good way to look at it. So when the lines of node line up, let's say at a full moon or a new moon, that's when we can experience eclipses. At the other positions, you'll notice that the moon is slightly above or below the Earth, and so we're seeing our phases. So we'll only see an eclipse during a full or new moon when those nodes are lined up. So during a lunar eclipse, we have the orientation like this. The Earth is between the sun and the moon. So a lunar eclipse is caused by the Earth's shadow covering the moon. Now what's cool is a lunar eclipse is red in color. And this is because around the Earth we have our atmosphere. And the atmosphere is going to bend solar light. So when sunlight comes through our atmosphere, it bends light into the red wavelengths. It refracts it to the red wavelengths, causing a red light to shine on the moon. This happens when we hit the most dark part of the shadow called the umbra. When the moon is in the penumbra shadow, it's not quite going through our atmosphere, and so we still see the grayish white moon that we're used to, just being covered up slowly by the Earth's shadow. So that's a lunar eclipse. So take a moment to answer this concept question. When the moon is between the sun and the earth, what do we see? So pause the video and take a moment to think about it. All right, so if it's between the sun and the earth, we see a new moon. Now, if it's lined up exactly, we could also see a solar eclipse. So when the moon covers the sun from the earth, we're able to see a solar eclipse. And when the sun is blocked out, we're able to see the solar corona, which is that thin atmosphere of the sun. So total eclipses occur when the umbra of the moon's shadow, just like we talked about, that's the darker part of the shadow with the lunar eclipse. We have the same thing with the solar eclipse, both the umbra and the penumbra. When the darkest part is in the shadow, that's when we experience a total eclipse. Partial eclipses are going to occur when the moon goes through the penumbral shadow. So it's interesting to also remember that the moon's orbit is not exactly circular, and so sometimes the moon gets a little bit further or a little bit closer to our Earth. That means it's not always going to cover up the sun exactly. So sometimes it won't have a total solar eclipse, it will have something called an annular eclipse. So let's look at the different types of eclipses. So here's a total solar eclipse. So the moon is between the Earth and the sun. So the moon's shadow is cast on the Earth. And if you look at the image in the upper part of the slide, that's an image from the International Space Station showing the shadow of the moon during a solar eclipse on Earth. I think that's pretty cool. There's a video down there if you would like to watch. So here's the corona, that atmosphere of the sun that's created during a solar eclipse. We're only able to see that because we're blocking out the really bright part that we normally see. So partial eclipses are when we go through the penumbra instead of the umbra. So a partial eclipse would look something like this. You're partially covering up the sun. But what about when the moon is farthest from the Earth at a point called apogee? That's when we get an annular eclipse. So only part of the sun is covered up and it looks like a thin ring, something like this. This is an annular solar eclipse. So these are two charts here to look at annular and hybrid eclipses and then solar eclipses. So notice that we had a solar eclipse go across the United States in August 21st, 2017. Our next one across the United States will be in the year 2024. But if you want to travel this summer, in July 2019, a solar eclipse will be happening over South America. So check out where you are around the world and see when the next solar eclipse could occur in your area. So I went to Oregon for the solar eclipse of 2017, which has been kind of dubbed now the Great American Eclipse. And of course, when you watch an eclipse, you want to have eclipse glasses to protect your eye from the sun, because solar eclipses are only going to happen for about 3 minutes. Otherwise, it's in partial eclipse, so you're getting a lot of that sunlight still. So you want to use your glasses. I'm the one sitting there with the braids in my hair looking too happy, right? It's a really fun event. So here's when the sun is just starting to be covered up, so it's partial. Here we hit what's called the diamond ring effect, when the sun is almost completely covered up, but the last little bit creates this beautiful shining last little light called the diamond ring. And then finally, totality, total solar eclipse. So I put some videos on here. They're also on the module to help you review over the moon phases, lunar eclipse, and solar eclipses. I really think these videos are helpful, so please watch them. It explains things with some more images and some simulations, which I think help a lot. Okay, that's all I've got for you for this week. So hope everything's going well with your module, and I will see you guys next week.